Yesterday, you were asked to complete example number 7 yourselves at home, where you were asked on a position time graph that was curved to find the instantaneous velocity at a specific moment in time, specifically 6 seconds. What does instantaneous velocity mean? Yeah. Yes, the velocity at a specific moment in time. Now, if we had a nice straight line graph like this, which was position versus time, and I was asked to find the instantaneous velocity at this moment in time, it's actually pretty easy because the velocity is constant. And if you find the constant velocity by taking the slope, then the instantaneous anywhere along that line is just going to be the same, right? So once you find the v is equal to d over t, delta d over delta t, or the slope of the graph, you've got the instantaneous anywhere along that line. Easy. But when you get a question like this where it's curved, you can't do that. Nor can you do what people always want to do for this. You say, well, oh look, wouldn't it be easier at 6 seconds just to say that's d and that's t, and then we just use v is equal to d over t? No, it wouldn't be easier. Well, it would be easier to do that, but it would be wrong. And it's wrong because velocity is not position over time. And that's what we've just done there, right? Position over time. Velocity is change in position over change in time, displacement over time. So we can't do this. We have to get a change in position and a change in time. But how do we do that when we're looking at one specific moment in time? There is no change of position or change in time at one specific moment in time. Well, this is where we got to draw. You remember what we called it yesterday? We got to draw a tangent line, right? A tangent line. When you skip rocks off of a river or a lake, the rock bounces off at a tangent to the river or to the lake. It just bounces off one point. It doesn't go into the lake. A tangent line doesn't go through the lake, okay, like this. That's not a good tangent line. That is an intersecting line. A tangent line doesn't do this. It doesn't go through all kinds of points in the lake, right? The rock bounces off one spot on the lake. So we need our line to bounce off. We need our line to bounce off one spot on the lake. Let's do that. Now, it's a little harder for me to do this up here with the line drawing function that's on the smartboard, but do our best here. It should look something like, nope, that one's not very good. Why is that one not very good? It intersects multiple points. That's like the rock, right, hitting the water and like kind of going through the water a little bit. It doesn't do that, right? It bounces off one spot. So that's not right. Let's try that again. Well, that's not right because that doesn't actually hit it at all. But I think my angle is right there, so I'm just going to click this and move it a little bit, see if it makes it better. Yeah, how's that? That's pretty good, right? It's not perfect. Man, you're never going to get it perfect, right? Everybody's going to be ever so slightly different, but it's pretty good, right? We got to bounce it off of this one spot. You can see that it's kind of even, right? If I drew it like this, it's like it's going through a bunch of points there, more on this side than on this side. The one that I just drew looks to be a good rock skipping technique right there. Good rock skipping technique. Got it? Now what do you do with this? Find the slope. And you can find the slope using rise over run or delta y over delta x, or you can just say delta d over delta t. That's the slope, right? Yeah, I'm going to do that. But in the end, it ends up being the same thing. Now, what delta d do I use? Let's pick a couple points. Yours are going to be different than mine, right? Because your tangent line is going to be a little bit different than mine. That's okay. Your answer should be still more or less the same as mine. We've got, let's go this point right here. Let's just go to the start and the end here, okay? Whoops, oh, shoot. It was all good there. Let's go to the start and the end. There we go. Start and the end. Now, delta D, what is that? Well, looks like a final position. It's kind of hard to tell exactly. I got to back up a little bit. Looks like it's about, what are we going up by on the y-axis? 410, 20, 30, 40, no, that's not it. 420, 40, 60, 80, no, that's not it. What is it? What are we going up by? We're going up by 40s, right? So this would be 440, 480, 520. It looks like about 530-ish. Does it? Looks like about 530 on there. So I'm going to say 530 meters minus, what's my initial position? 0. Yours isn't necessarily going to be 530 minus 0, right? In all likelihood, it won't be 530 minus 0. Like, it's quite a coincidence, actually, if it's exactly the same as mine. Delta t, my final time is 8 seconds. And my initial time is, what are we going up by on the x-axis? 0.4. 2.4, 2.8, what is that, Xander? About 3? So 8 seconds minus 3 seconds. Like maybe it's 3.1, I don't know. But it's pretty close, right? So we're going to say 530 meters divided by 5 seconds. What is that going to be? 106 meters per second. That's pretty fast. 106 meters per second. Whatever that object is moving at about 350 kilometers per hour. Does that make sense, guys? Okay, let's have a look at the worksheet question that goes along with that then. That would be worksheet number 3, question number 12. Worksheet number 3, question number 12. You're going to have to, or you may have to, do a little estimating on this one. So we'll do this to see what we get here. We got to pick 2 points on the line. We want to make our points far apart, by the way. I don't know if I ever mentioned that to you. Sometimes people like to say, like, well, I'll pick a point here and a point here because they're nice and easy to determine they're on intersecting lines. Or don't do that. Okay, I don't care if they're on intersecting lines or not. You want to pick 2 points that are far apart. Reason being, if you're off by a tiny little bit in your measurement, you're okay if you pick 2 points that are far apart. Like imagine this. Imagine I pick 2 points that are really, really close together, or really, really far apart, sorry. And I'm off by 0.1 in my measurement. So let's say I've got 10.1 minus 1.1. And it was really supposed to be 10 minus 1.1. Make sense? But I made a mistake and I was off by 0.1. Okay, that's not a huge deal, right? I'm off by 0.1, but the difference is 9. So what's 0.1 at a 9? It's not a very big deal, right? But if I said, well, these are perfect points, I'm going to take these, 1.3 and 1.1. But I was off by 0.1 there. It was really supposed to be 1.2. Well, that 0.1 that I'm off by is a much bigger deal now, isn't it? It's a much, much more important error that I've made. So that's why we want to pick 2 points that are far apart, because it allows me to make a little error in that and still get away with it, right? 58, 60, 57, whatever, right? Make a little error with it. We all got away with it, right? But if I pick 2 points that are close together and I made that error, then maybe somebody gets 51 or something like that, right? Okay, so pick 2 points that are far apart. If you got convenient points, that's great, but whatever, not a big deal. Let's pick this one. And it's hard to see close up here. Let's pick this one right here. Those are far enough apart, I think. The slope of this is the instantaneous velocity. Okay, let's say displacement divided by time. Looks like 500 minus 0. That's a nice easy one to do. Over the time, what is it? 12 minus, what is that, 2.4, 2.8, 3.2? Man, it's hard to see it close up. Can you guys see it better than I can? Those lines are really hard to see, right? 500 divided by 12 minus 3.2. Let's figure that out. When I do it this time, I get 57 meters per second. In my answer key, I think I said I had 58 meters per second. Well, when I drew the tangent line on my answer key, it's probably a little bit different, right? Or I was off by a tiniest little bit in my determination of my coordinates there. But again, it's not a big deal. Because I picked my points far apart, I got away with it. My slopes in both cases are really, really close together. Good?